Hi everyone, myself and Arun Kumar from SNS College of Technology in the Department of ECE. In this video, we are going to discuss about switched capacitance minimization approaches. So one of the technique which is used to minimize the capacitance approaches is system level measurements, circuit level, MOS level measurements. So these are the approaches which is used to define capacitance minimization techniques for low power IC design. System level measurements, it's a global bus structure for transmitting the data from source to destination. So in that global bus structure, we can add more number of additional devices in a same bus, so that we can get the all the information in a same line. So if a single bus is connected to all the modules, then the result of the capacitance is the large number of drivers and receivers sharing the same transmission medium. And second one is the passive capacitance of the long bus line. So let us consider this diagram. First diagram shows that one bus is connected to all the terminals. So only one capacitor is connected, so that it just passed the all the stored voltage can be passed to all the terminals which are connected through bus. And second one is bus terminal, which is connected as a series one. So in that method, all the capaciting terminals on their corresponding voltage has been moved towards the all the terminals by connecting two-way of communications, so that it may get the information in a proper manner, even if the transistor, even if the information which is carried over the capacitor is failure, then it also get the information from the upper layer. So this is what the information which is used to reducing the switched capacitance, because we are main focusing about to reduce the voltage for operating the information, so that we can use this model for reducing the capacitance. So nowadays we are using super capacitor buses. For example, if you are using electrical vehicles that need a charge, that kind of capacitors are rechargeable one. So it is also used for electrical buses also. But the thing is, the huge bus which is having more number of capacity of the capacitor, so that we can use multiple number of time for recharging. So we need to consider for the capacitor while designing a large number of capacity to use the particular for bus terminals. So here that they are having values which is for user in buses. Initially, it provide a voltage like 400 to 600 volts. Once if you are charging the capacitance, we can move up to 35 kilometers for this type of capacitor. Here they are using a hybrid lithium ion supercapacitors. So it especially for this capacitor, the following specifications should be there. Charging time is 5 to 10 minutes. Once if you are charging 10 to 5 to 10 minutes, then it can move up to 35 kilometers. The weight of the corresponding capacitor will be 1450 kilograms. And next one is once the information, the capacitive information is stored up to 90 service life cycle, we can use up to 90,000 times we can charge for capacitor. So these are the basic constraints we need to consider for this hybrid lithium ion super capacitors. And next one is circuit level measurements. The capacitor is the function of number of transistors in the logic circuits. Next one is they use pause transistor logic for making a circuit level measurements. Here they are using a XOR gates for making a circuit level measurements. So the circuit level measurements initially framed by using a logic gate operation. They are using here as a XOR logic. So the XOR logic is in a parallel mode, like AND gate is used for AND gate, and AND logic is used for a series mode. So next one is pass gate logic. The main function of the pass transistor logic is used for NMOS and PMOS transistor to transfer the charge from the input node to output node. Under the control of this stage, gate voltage has been compromised by using this pass transistor logic. The output remains in high impedance state with gate voltage is zero. So the main operation of this pass transistor logic is the gate function is zero. The corresponding voltages of the pass transistor logic is Vx equal to minimum base voltage minus Vt threshold voltage into input voltage Va. So NMOS gate construction based on this uh, parallel mode and serial mode, the corresponding truth table has been formed with the help of this gate construction. So like that PMOS also, because it's the inverse of NMOS, so that we can add easily based on the previous gate operations. MOS level measurement. Sometime if we are making more number of ICs in a chip, we can have a MOS level measurements. That MOS level measurements are used to make more number of chips at a time. Sometime fabrication problems or any leakages occurs in the circuit means we can use this MOS level measurement so that we can eliminate an error or leakages in the particular reconnected unit, because it just formed based on the format having error for found on error method. Particularly, this method is applicable only in matrix format. If here we have to check the images of the corresponding corresponding IC so that we can have errors or any delays or any leakages in this terminal is easily we can able to identify the by using this muscular measurements. So the hyphen is shows that how this mask is carried out through the entire chip. Mask level layout. After finalizing the mask, we can have a chip level transmission. So before going to analyze this unit, we need to check this mask layout so that we can get the information as without any delay, or else we can't get any leakage or power dissipation in the unit. Next, what factors should be considered when placing a bypass capacitor on a PCB? While placing a bypass capacitor in a PCB, it just having a power consumption as a low one. So that is why we are focusing on bypass capacitor in a PCB, because it's a bypass. If you are having a large number of voltage in the circuit, then it is bypass their voltage to the next medium or next level. It just consume only the low voltages in this bypass capacitors. Thank you.